Hi guys, today you're going to be looking at the second problem solving strategy, guess, check and refine, sometimes called trial and error. So trial and error is a useful problem solving strategy. Its only drawback is that for some problems it is too slow and time consuming, and that's because we're guessing, we're checking answer, and then we're going back through the cycle if we've gotten it wrong. So it involves 3 steps. We guess a value to solve our problem, check to see if the value makes sense and solves the problem, and then refine means choosing a new value if it didn't work out the first time. So if we have a look at this question here, it says Charlie is 5 years older than Lola, and twice Charlie's age plus 3 times Lola's age is equal to 25. What are the ages of the 2 children? So there's a lot of numbers here. We want to know what the question is actually asking us, and the question is, what are the ages of the 2 children? So how old is Charlie and how old is Lola? Now, in this question, we actually have 2 unknown values. We don't know Charlie's age and we don't know Lola's age. So we can't use the strategy that we were using yesterday, which was just computations, direct computations with this information. We're going to have to guess one of their ages and then figure out the other age. So I'm actually going to draw a guess and check table. My first column is my first unknown, so I don't know Charlie's age. So Lola's age is my second unknown, and that's Charlie's age take away 5. Since Charlie's 5 years older, the total when we do our sum is going to be 25, and that's what we're working towards. And then our last column is check to see if we've got it correct. So I'm just going to guess Charlie's age, and I know he's a kid. It's going to be less than 25, so we're just going to guess about halfway and go with 10. Now that makes Lola's age 5. And now we're going to do this sum. So twice Charlie's age is going to be 2 times 10 plus 3 times Lola's age. So plus 3 times 5. So in our total column, we're going to write 2 times 10 plus 3 times 5. Now 2 times 10 is 20, 3 times 5 is 15, which gives us a total of 35. So that is too high. So we need to lower Charlie's age. So we're going to guess a new number. And I'm not going to go 1 down because it is pretty high. I'm going to guess 2 down. So I'm going to guess 8, which makes Lola's age 3. And then we would do our sum. We're going to do 2 times 8 plus 3 times 3. So 2 times 8 is 16 plus 3 times 3, so plus 9, is going to give you 25, which is just right. Now, because it is a worded question, and if someone was looking at this table, they probably wouldn't be able to figure out what we were talking about. So we are going to put ... I forget what this one's called. Charlie is 8 and Lola is 3 years old. That ... means therefore. So you can say from our working, therefore Charlie is 8 and Lola is 3 years old. Let's have a look at one more example. Sandra's cycle repair shop fixes normal bicycles and tricycles. Sandra had to assemble a number of bicycles and tricycles. She counted 15 handlebars and 36 wheels among the parts she had to put together. How many of each type of cycle were to be assembled? Now there's a lot of information there, a lot of information we don't actually need, but let's look for the question, and that is how many of each type of cycle were to be assembled. Now this is important because Sandra wouldn't want to make too many bicycles and not have enough tricycle wheels and then not be able to produce her orders. Another piece of information first is that there's 15 handlebars, and that tells us that there has to be 15 cycles in total. So that's going to help us in our table. So I've got a column for my first unknown, bicycles, another column for my second unknown, tricycles. My third column is what we're working towards. So we know that there are 36 wheels, and then we're going to check to see if it's correct. Now remember, if there's 15 handlebars, then the number of bicycles plus the number of tricycles have to add up to be 15. So I'm just going to pick 2 numbers halfway between 15 and see how they go. We can't have half a bicycle, so I'm going to pick 7 bicycles, which means there's 8 tricycles. Now bicycles have 2 wheels, tricycles have 3 wheels. So our number of wheels over here, we're going to show our working. We're going to do 7 times 2 for the bicycles plus 8 times 3 for the tricycles. And that gives us 38 wheels. Now that's too many, that's too high, so we're going to go back through the process. If it's too high, that must mean we need less wheels over here, so we need less tricycles and more bicycles. 36, let's try 10 bicycles and 5 tricycles. There we go. So 10 bicycles is going to be 10 times 2 plus 5 tricycles is going to be 5 times 3, which gives us 35. So we're actually pretty close to 36 here. I thought that would be a little bit off, but that's okay. But that's still too low. Too low means we need more wheels, so we're going to need more tricycles. So let's try 9 bicycles and 6 tricycles. And look at that. 9 times 2 plus 6 times 3 is 36, which is just right. And we are going to finish with a sentence, just a little one. We're going to write therefore with our ... There are 9 bicycles and 6 tricycles to be assembled. Now you're going to do a couple activities today. Hope you have fun and I'll see you soon.